Hey guys, today we're going to talk about something called the converse of the Pythagorean theorem, or the Pythagorean theorem converse. And in order to understand how we can use this, we're going to go right to just a question and try to figure it out. The question that we have, it's on the first slide. It says the measures of three sides of a triangle are 10 inches, 24 inches, and 26 inches. And we want to figure out if this is a right triangle. The question says, is this a right triangle? So in order to do this, we need to kind of look into right triangles. And I'm going to talk about some of the important vocab and the relationships. So in a right triangle, we know there's a right angle. We know the two legs are the two sides that make the right angle, and the hypotenuse is across from the right angle. It's also true that the hypotenuse is the longest side in every right triangle. So the side across from the right angle is always going to be the longest side. So let's go ahead and go back, knowing that now, go back to our triangle here. This doesn't have to be a right triangle, but we can test to see if it is. If this is a right triangle, well then 26 is the longest side, so that would be your hypotenuse. If this is a right triangle, this would be your hypotenuse. This would be a leg, and this would be a leg. Now, if it was a right triangle, remember Pythagorean theorem, a squared plus b squared equals c squared. This only works in right triangles. So if this is a right triangle, then when you substitute in your values for the legs and substitute the value in for the hypotenuse, it should satisfy the equation and make it true. So all we're going to do is we're going to take, well, 26 is the hypotenuse. So let's put a 26 in for where the hypotenuse goes. 10 is one of your legs, so we're going to put a 10 in for one of the legs. And 24 is the other leg, so we're just going to substitute straight across. Leg squared plus the leg squared equals the hypotenuse squared. And when you do a little bit of evaluating, 10 squared is 100. 24 squared, we should get 576. And 26 squared, we should get 676. When you add your like terms here, you get 676 equals 676. Since this is true, since this works, that means this is a right triangle. So we know this is a leg, we know that this is the hypotenuse, and now we know this is going to be a right angle here. So yes, it is a right triangle. And that is what the converse of Pythagorean theorem is. It's taking the sides, if you're given them, and figuring out if it is a right triangle based upon does it make the equation work, the Pythagorean theorem work. If you want to take notes down on the particulars of this, the second slide really goes into detail. I'll read over what it says. It says if the sides of a triangle have lengths a, b, and c such that a squared plus b squared equals c squared, then the triangle is a right triangle. So the converse of Pythagorean theorem is used to determine if you have a right triangle, if you have that right angle in there. And if it doesn't make the equation work, like let's say you had a squared plus b squared and it didn't equal c squared, then you would not have a right triangle. But if it does work, then you have a right triangle. That's all this converse is doing. It's telling you whether or not you have a right triangle, whether or not there's a right angle involved. So if it works, like we just saw, great, we have a right triangle. If it doesn't work, well, that just means we don't have a right triangle. There's no right angle. So we have 4 different examples that we're going to go through. And for these examples, we're just given 3 measurements, and we have to determine if the 3 measurements make a right triangle. So the first 3 we have, I'm going to write them over here. We have 9 centimeters, we have 12 centimeters, and we have 16 centimeters. And we want to figure out if this is a right triangle. Again, looking at the 3 of them, if it is a right triangle, the longest side is going to be your hypotenuse. So when we go to a squared plus b squared equals c squared, the longest side is 16. That's going to be your hypotenuse. So 16 squared. And the other 2 sides, well, those would be your legs. So 9 squared is 81, plus 12 squared is 144, and 16 squared, we should get 256, I believe. Let me double check myself. 16 squared is 256. So 81 plus 144, let's make sure and see if that equals 256. And if you go ahead and add those together, you get 225, which clearly does not equal 256. So that means these three sides, they do not make a right triangle. They still make a triangle, but there's no right angle in the triangle. So not a right triangle. That's what we can conclude for the first one. On to our second example. Let's go to blue. So our second example, we have the measurements: 8 centimeters, 15 centimeters, and 17 centimeters. Now these three, we're going to go ahead and check, see if they make a right triangle. So look at the three measurements, 8, 15, 17. If they are the sides of a right triangle, then 17 would be your hypotenuse. That's the longest side. And your other two measurements would be your legs. So 8 squared, you should get 64. 15 squared, you should get 225. And 17 squared, you should get 289. So when you go ahead and combine your like terms over here, well, you'll end up with 289 equals 289. This is true. So that means we can conclude that these three sides, they are the sides of a right triangle. And you could even go further and say 8 and 5 are the legs, and 17 is going to be your hypotenuse here. So these do make a right triangle. 17 will be your hypotenuse. All right, if you want to try the other two on your own and then go ahead and check with what I do here, you can do that. If you're feeling okay, you might want to skip forward. There is a little more after these two examples. So our next example, we have 10 inches, 28 inches, and 24 inches. So when you look at these three measurements, if this is a right triangle, we'll look for your longest side. 10, 28, 24, that would be 28. So 28 would be your hypotenuse. And then 10 and 24 would be your legs. So 10 squared, we should get 100. 24 squared is 576. And 28 squared is 784. So when you add together, you get 676 equals 784. Well, that's not true. So that means these three sides do not make a right triangle. There's still a triangle, there's just no right angle with those three side measurements. All right, and our last one, we have three side measurements down here. And they are 10 feet, 6 feet, and 8 feet. So for these three, if this is a right triangle, then 10 is clearly your longest side. So 10 would be your hypotenuse, and your legs would be the 6 and the 8. So 6 squared plus 8 squared equals 10 squared. 6 squared is 36. 8 squared is 64. And 10 squared is 100. When you add 36 and 64, you get 100. And 100 does, in fact, equal 100. So therefore, these three side measurements form a right triangle. And you can go as far to say 6 and 8 are your legs, and 10 is your hypotenuse here, the longest side of the right triangle. But it does, in fact, make a right triangle. So one of the other things I want to talk about with this is something that'll make, the more of these you know, the kind of the better off you are. There's something called a Pythagorean triple. Now, Pythagorean triple are just combinations of side lengths that make right triangles. The most famous one, and the one you probably definitely should know, is a 3, 4, 5 triangle. Meaning if you have a triangle with side lengths 3, 4, and 5, whatever the unit is, it's going to be a right triangle. You can plug them in. 3 squared plus 4 squared equals 5 squared, and you'll find out really quickly that it works. So instead of having to do the work every time, whenever you see 3, 4, and 5 for a triangle, you know it's a right triangle. Some of the other ones that are kind of memorized by people, well, one of them we just looked at, we just had in here, was an 8, 15, 17. That's another Pythagorean triple. And there are some others. There's the 5, 12, 13. There's an infinite amount of Pythagorean triples. And if you know them, it can just make doing the work a little bit easier. There's also something called multiples of Pythagorean triples. And that can be really useful when you're trying to figure out if something's a right triangle or not. So a multiple of a Pythagorean triple is like, let's take a 3, 4, 5. Let's say you have side lengths 6, 8, and 10 like we just saw. Notice how you take a 3, 4, 5 and you double everything and it equals 3 double is 6, 4 double is 8, 5 double is 10. This is just a multiple of a 3, 4, 5. Now you really don't need to memorize any of the Pythagorean triples, but if you know them, you can find right triangles a lot quicker. If this kind of interests you, you can do a little research on them. They're kind of cool. If you know them, you know right triangles really quickly, and then you don't have to do all the calculating because you just know it's going to be a right triangle. Like if you had maybe 12, 16, and 20. This would also be a multiple of a 3, 4, 5. If you multiply all of these by 4, 12, 16, 20, that's going to be a right triangle. It's a multiple of a 3, 4, 5. So these side lengths would end up being a right triangle as well. Knowing Pythagorean triples can be really helpful. Not knowing them, it's okay. You just have to fall back on using the Converse then. Alright, that's all we have for today. Have a nice day, guys.